Okay, so let us start while waiting for others to come. So today we are going to discuss chapter 3 of our lesson that is about alkenes and alkynes. Actually, if you talk about these hydrocarbons are classified into 4 types. Okay, so the first one is about alkanes. Okay, the one that we had discussed in chapter 2. Alkanes has a single bond, then followed by alkenes. Alkenes has a double bond. Alkynes has a triple bond. And the aromatic hydrocarbon, which is incurred with the benzene ring, so-called aromatic because of its sweet smell. Okay, that is another part that we are going to have. So let's move on. So what are alkenes and alkynes? So alkenes is unsaturated while alkane is saturated. Okay, what do you mean by unsaturated? Meaning because of the presence of the double bond, what happens is it has less number of hydrogen. Instead of, diba, it will start with CH3, then CH2, CH2, CH2. Because of the presence of the double bond, what will happen is instead of 2 hydrogen, it will have 1 hydrogen. Okay, CH, then double bond like that, then CH. Okay, so that makes it unsaturated hydrocarbon, meaning it contains a carbon-carbon double bond. While an alkyne, remember, this is pronounced as alkene, this is alkyne, Y-N-E. Okay, you will know it is a single bond. That is why in the naming of the alkane, it ends with A-N-E. That is methane, ethane, propane, butane, like that. But for alkene, it will be methane, like that. Methane, then butene, propene. While for the alkyne are same thing, unsaturated hydrocarbon, because what happened here is because of the presence of triple bond here. So in ethylene, we have a double bond here. Huh? So in ethylene, it is an alkene, or you can name this as ethene, okay, or ethylene. So there is that double bond. What happened to your, no, to your hydrogen? There will only be 2 hydrogen in each carbon. Okay? Instead of having it 3, di ba? Ang pinaka-last is 3. Ang pinaka-first is 3 hydrogen, ug ang last is 3 hydrogen. Then, by having the homologous series, it will follow with by 2. That is CH3, CH2, 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 so on and so forth. And the last one is CH3. Always remember that. If and when there is a double bond, that will be minus 1 hydrogen in each carbon. So you will have CH2 and CH2, then double bond. For alkyne, it is a triple bond. No? So if it is a triple bond, what happened here is if it is in between, for instance, CH3, then C, triple bond, then C, there is no hydrogen. Why? Because this is substituted with the presence of the triple bond. So it is here. But since this is the first and the last, so it will still have 1 hydrogen. Okay. So that is the definition of an alkene and an alkyne. Alkene is unsaturated hydrocarbon that contains a carbon-carbon double bond, while an alkyne is unsaturated hydrocarbon that contains a carbon-carbon triple bond. Okay. So what happened here is how this is being produced. This is being produced by means of a higher temperature. It is known as the thermal cracking. Okay, so the reaction here, that is why in most of the the hydrocarbons, especially for the alkene and alkyne, it is very unreactive. Nga naman, because it needs a higher temperature so that will be converted into an alkene. For instance, we have an ethane. It will be converted into ethylene by means of thermal cracking at a temperature of 800 to 900 degrees. So from ethane, that will be converted to ethylene or ethene by means of thermal cracking. So what is the structure of an alkene? So here it is the alkene. This is the ethylene. Ethylene has this. Okay, it has that double bond. That double bond with your hydrogen, it has a 121.7 degree. Okay, the angle. While for the propene, it has a so-called angle of 124.7. Okay, samok baning na nag-ayo. Why magkuan, why mo why mo adto nga dos gawas. Okay, so it could either be in the alkene, it has that stereoisomerism. What do you mean by stereoisomerism? Meaning they have the same thing. Still remember that one? They have the same molecular formula, but they will differ in the orientation of the molecules. In what way? No? We have the cis and trans isomers. What do you mean by cis? No? Cis is meaning it is on the same side. No? Cis and trans isomers, what are isomers? That isomers is they have the same connectivity of their atom, but they will differ in the arrangement of the atom in space. That is why it's so-called cis and trans isomer. But if you're going to get its molecular formula, it has the same molecular formula, but it will just differ in the orientation of the atoms in the molecule. For instance, this one, no? This is butene, but this has, no? This has an arrangement of the atom in the cis. What do you mean by cis? Meaning it is on the same side. Asaman ang same side sa methyl. Okay, here on the down. Pwede po na siya katos ibabaw. Okay, basta same side. And that is cis. No? Cis to butene. Here we have trans to butene. Why trans? It is on the opposite side. Okay, no? Take a look. Your methyl here is on the opposite side with the other methyl here. No? So this is cis-butene. This is trans-butene. A minute. Kaya na ay nagsaba-saba ako sang anak kong anak. Okay.
Marag naka-mute ka, ma'am.
Excuse me, ma'am. Hello?
Huwag mo din ako
Nakamute ata
ma-unmute.
ka,
Oh,
ma'am.
sorry. Okay, no? I repeat, binuang, no? Sorry. By the way, no? What do you mean by pheromones? Pheromones, these are chemicals, no, which is being igawas ni sa mga animals for them to be known that they are in heat, okay, or they are fertile. Kita mga tao, wala na sa ato ng mugawas gawas mga chemicals in our body. Wala, no? What is being instigated in us is our smile, our action, no, our sight, like that. Okay, no? Kung kagusto, okay, ipakita, no? Or madunggan. But for animals and for insect, wala na sa ila. What they have is the so-called pheromones. So pheromones is a chemical substance, no? That will be emitted in their body in times that they are in heat. Okay, so one of the things which is being found out here is there are, no, in the corn borer or stem borer sa corn, no, there are two types here. That is the trans-11 tetradecynyl acetate. The other one is the cis-11 tetradecynyl acetate. Take a look, no? This cis is 3% effective, but ang usa is 97%. That is the trans isomer. So even though they have the same, no, they have the same molecular formula, but they will differ in the orientation, in its structure, at the same time its effectivity. Okay, so that's it. So what are alkenes and alkynes? How are we going to name the alkenes and the alkynes? Okay, so we will be using the Apiopac way of naming an alkenes. An alkenes ends with E-N-E, while alkane ends with A-N-E. Okay, it's almost the same. The first thing that you're going to do is you find the longest continuous chain to be your parent name. Okay, find the longest continuous chain to be your parent name. That is for the alkane. No? For the alkene is i-include na nimo ang double bond. Okay, so find the longest carbon chain that includes the double bond. And of course, it will end with E-N-E. So the number of chain that gives lower set of number to carbon atoms of the double bond. Aron pa masabtan yun ni siya is, for instance, na you have CH3, CH, then double bond, then CH. Okay. Then, naapong nagtua sa, naapong sa tunga-tunga po. Okay. So, what happened is, you will select, where are you going to count your carbon 1? Carbon 1 should be selected in a way nga mas duol siya sa double bond. I repeat, your carbon 1 should be selected, diba? In counting it is carbon 1. No problem with alkane, kay pareho raman na siya. Ang unahon lang nimo sa alkane is asa dapit ang mas duol nga substituent. Katong substituent is katong na ay branching, no? But for the alkene, it's different. Unahon nimo tan-aw ang dili ang branching, kundi asa dapit ang double bond, no? Kung ang double bond naanga ni duol sa carbon number, gani adapit nga carbon, no? It's in carbon 3, while if you're going to count it on the other side nga carbon, naana siya sa carbon 6. Sugod yung ka sa pinakaduol. And that is what is meant by this number 2. So the branch of alkanes are named in the same manner with alkanes. It's still the same. If it is bromo, chloro, start with the alphabetical arrangement. The methyl, ethyl, so you start with ethyl, then methyl, like that, okay? So for instance, we have here, okay, here, no? This is the structural formula, no? That is CH3, CH2, 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 CH, then double bond CH2. Okay, Ingon ko sa inyo, basa na gani double bond, diba? This is homologous series, CH2 unta ni siya. But because of the presence of the double bond, kanang usa ka bond, that will reduce one hydrogen. So it's no longer CH2 here. It's no longer CH2 but CH. Di ba kani CH3? It will be CH2. Nga naman, this one bond niyan hiya will have two hydrogen. Did you get it? Okay. So we will not name this as this will not be carbon 1. Nga naman. And the rule for naming an alkane, you start with where is the nearest double bond. It is here. The nearest double bond is here. Therefore, you should count this as your carbon 1 and to this. This is what? It is now 1 hexene. You're going to place where is your double bond. So if it is here in carbon 3, you should place there 3 hexene. Okay? If and when, oh, I forgot. This is the line. No? Mas dali maghimo og naming sa line. Line mga bata, ha? How are we going to have it? Diba? Ang line is, pag start yung kagpasaka, then naog, ano na siya? Saka, naog, saka, naog, saka. Okay. Kada ed ana mga bata is your carbon. Na? So, kana na carbon nga na. Na carbon nga na, carbon nga na. Carbon, 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 carbon. So, how many carbon? There are 6. So, in carbon 1, there is double bond. So, buta nga na po ni mong anak. Kung ang carbon 1 na ay triple bond, buta nga po ni mong tulo na nga. Di ba masayon? No? So, it's easy to write by means of a line, no, structure compared with this structural formula. Okay, another one, another example. This is, sa to unahon sa nimo asa dapit ang double bond. Oh, it's in carbon 1, no? So you should start counting this as 1, 2, 3, 4. Kung kana imong kuhaon nga 5, mas taas pa man ning 6. So you will no longer use this as your, if you are going to 1, 2, 3, 4, 5, dili ni siya mao. It should be kaning straight. This will be a substituent lang. This will be a so-called attachment. Okay. So you have a methyl attached to this hexene. Na? So unahon sa ang name ang mga branch. Na? Where is our branching? There is 4 methyl. Na? 4 das methyl. Then where is our double bond in 1? What is our parent name? Hexene. Okay, you get it? Therefore, the name of this is 4-methyl-1-hexene. What's the line? Okay, more hapon. That is 1, 2, 3, 4, no? 4, 5, 6. Okay. At 4 na ay methyl. Butang na po ni mo, ana. Because usa ka ana is methyl. Kung maduha na ni mo ana, that is already ethyl. Okay? So, that is it. Therefore, the name of this is 4-methyl-1-hexene. Kani. Kani po di mang maklaro. Ako ipataas na anak. Okay. Here, we have how many branching? Sige. If we will count this as carbon 1, 1, 2, 3, 4, 5. Pwede po. Pero what happened is, much easier na siya kung straight nga niya. That is 1, 2, 3, 4, 5. No? Where is our double bond in carbon 1? In carbon 2, there is, what is this? There is ethyl. In carbon 3, there is ethyl. So how are we going to have it in a straight, in a line? Line formation, line structure. That's 1, 2, 3, 4, 5. At carbon 3, there is an ethyl. Kung ethyl, paana, pwede po na siya. Paana, pwede ba? Basta kay na ay duha ka branching. Na? Duha ka ana nga carbon. This one, that is how are you going to count this? This is here. In carbon 2, there is an ethyl. This is 1 carbon, another carbon. So this is ethyl. Now, what's the name of this? That is 2, there is an ethyl at carbon 2. There is an ethyl at carbon 3. Therefore, 2, 3. Then, how will you know it will be how many ethyl? You will be using the suffix, nah? That is prefix, prefix that is di, tri, tetra. Di for duha ka buok, tri, tulo, for tetra. Wa na mo, di na mo sobra ana, murag kutob ra gyud na siya tetra. Therefore, 2, 3 diethyl asa imong double bond sa 1 pentene. Because this is 5 na carbons, it's pentene. So that is how you are going to write and name, no, a double bond, an alkene. So be sure to practice. Mga bata, kinalan lang yun ani is practice. Okay? So let's move on. So, how are you going to name alkenes? Again, using an IUPAC name. The alkyne, it will end with Y and E. Same po ang process. No? It's the same. You are going to look for the triple bond. No? That is where you will start your carbon. The nearest triple bond mo na sugod ang inyong carbon 1. Okay? So, the number of the longest chain starting at the end closest to triple bond. So, one alkene is referred to as terminal alkene. Na? So, that is it. Same process also if you have a branching. No? You use the substituent, you use the alphabetical order also. Huh? Then, in case there will be more than one triple bond, use the suffix 2 di, 3 tri, 4 tetra. So, diene, no? 10 minutes na lang. Pag human na to ani nga tumuspikas na po nga kuan ha. Okay. Diene, triene, and so forth. Okay. So, an example for this we have here, no? Unya na ta mag-attendance sa next nga kuan. So we have here this structure here that is 1, 2, 3, 4. So it is butane. But there is a triple bond at 1, meaning it's already butane. So there is one butane, that's the parent, and there is a methyl at carbon 3. Therefore, the name of this is 3-methyl-1-butane. Okay? Here, how are you going to have it? So the line structure here is you have 1, that is 1 ka na nga na, 1 na, then 2 na siya. Okay. How many bonds? There are triple bonds. Okay. Ingon ko ba sa kada end niya, there is carbon. Is carbon 1, carbon 2, 3, 4. At carbon 3 na ay methyl. Okay, this is now the line. Na line structure. Another one. We have here this structure. This structure is, what is the name of that? That is 1, 2, 3. No? So at 2, there is triple bond. No? Then 4, there is a substituent chloro. At 5 na siya. Then 6, sa 6, naa siya pila ka buok. Naa siya iodo, nga duha. At 7, naa siya methyl. Then 8, 9. Look into the parent name. It's 9. Therefore, it's non-name. Diba? But since it is a triple bond, therefore, it is no-9. Okay. First thing that you're going to do is write now the triple bond as a dapit. It is at 2, not 2, no 9. Wala man siya duha or tulo usaraman. Then you have the substituent in an alphabetical order. There is chloro in carbon 4, that is 4 chloro. There is in 6 you have duha ka iodo, that is 6, no? That is 6. Sayop ni ha? It is 4 chloro, then 6, then ano na yun? 6, then kuwit 6. Diba man? No? That is 6,6-diiodo. Then we have 7-methyl 2-9. Kani ha? I-check na siya. That's 4 chloro, 6,6-diiodo, then 7-methyl 2-9. That's the name of that. Okay. This one. Okay. This is, where are we going to start counting our carbon 1? Dili nga niya. Okay nga naman. That is 1, 2, 3, 4. Diba? Pero kung ganito mag-count, it is nearer. That is 1, 2, 3. Therefore, let us have our carbon 1 here. That is carbon 1, 2, 3, 4, 5, 6, 7. So it is heptene. Okay. But in carbon 3, there is triple bond. Therefore, that is 3-heptene. Then there is 2 substituent of methyl in carbon 6. That is 6,6-dimethyl 3-heptine. That is it. Kani. Na? So the straight line structure, that is 1, 2, 3 na ay triple bond ganiya at carbon 3 and 4. Then 4, 5, then 6. At 6, you have 2 ka methyl. Na? At 6. Pero pwede na po na ninyo i-straight nga to ang mga bata paana. Kuana ni. Basta makitaan lang nga na ay structure. Okay. So that is 6,6-dimethyl 3-heptine. Okay. Unya na ka nag-ayo. So here it is again another carbon. Another structure, okay? Where is our carbon 1? No? Our carbon 1 will be dili pwede nga ang carbon 1. Kaya nga naman, asan ang triple bond? The triple bond, it is here. Therefore, our carbon 1 will be here. That is 1, 2. No? 1, 2, 3. Then 4, 5, 6, 7, 8, 9, 10, 11. That is design. Na on design. Naunta na siya. Design. Therefore, it is samok yun na siya, no? Sige, ayo. Saon taman nagklase man ko. Wa may tawlain. That is, there is na a methyl. What happened? There is a methyl here in 5, carbon 5. There is 2 iodo in carbon 2 and carbon 10. Diba? Therefore, that is 2, 4, 10. How many iodo? Triiodo, 5-methyl. Asa dapit ang triple bond, it is in carbon 3 design. Okay? That's the name of that. The next one, kani. No? So, hapit na ba mo end? Kung sa orasan na. Okay. This one again is this one again is, where will be our carbon 1? Asa man dapit itong carbon 1 na? Dili ta mag-carbon 1 nganhi ngano man. Our triple bond is, if we will have it here at carbon 1, that's 1, 2, 3, ika 3. But here it's in 1. So meaning this is where we are going to have our carbon 1. That's 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. But we have how many triple bond? It is in carbon 1 and carbon, pinta, 1, 2, 3, 4, 5. There is a triple bond in carbon 1 and 5, meaning that is octadiene. Ngano octa man? Because your parent name is octane. And there is a triple bond. At that, it is diene. And where is one of the substituent? It's methyl. Where it is? It is in 4. It is 4-methyl 1,5-diene. Okay, will you please let me show your faces so that we will have our no? We will have our pictorial muna. Okay, show your faces. Dali, kay hapit na time. Grabe. No? Arang ka sexy. Sige. Picture ta. Sige, dali. Picture, dali kay before you transfer to the next. Erica, Crystal, Jeffrey, picture. Show me your faces. Dali. Okay, 1 minute na lang. Erica, Jane. Dali. Hilay na ba ni kay mukalitrag kawala? Okay, so minute. One more. Sige, 1, 2, ready. Smile. Pud mo no sa mamuoy. Sige. Okay. So, let's end this. You go back to our katong next na pod nato nga at kaan. Mao na kay wala manggugay subscription, ma'am. Magkuang ka. So, let's end it here. Wait for me in di ba duha man to akong gikuan sa inyo ngadto na pod mo. Sige. Bye-bye. See you again.
Bye, Ma.